Okay, so number 9, if I look at number 9, it says let the point P be on the unit circle. And it says that the point P is at the point 2 pi. Find the coordinates of P, the exact values of the trigonometric functions of T. Okay, so it wants to know P of 2 pi. So where would you end up if you walk around 2 pi? Well, on the unit circle, if I go all the way around and stop here, my x and y coordinates are 1, 0, so that's my cosine sign. So that means that the sine of 2 pi is equal to my y coordinate, which is 0. My cosine of 2 pi is equal to 1. So my tangent of 2 pi is going to be 0 over 1, which is 0. That means that my cosecant of 2 pi is going to be 1 over 0, which is undefined. My secant of 2 pi is going to be 1 over 1, which is 1. And my cotangent of 2 pi is going to be 1 over 0, which again is undefined. So that is 9. So let's see if that's 9. It's 9a. And so for B, I'm saying what is the point if I go around negative 3 pi? So here, I first go around in the negative direction, so that's this way, 2 pi. But then I go around another pi, so I'm going to end up over here, where my xy coordinate is negative 1, 0, and that's my cosine sign. So in this case, my sine of negative 3 pi is equal to 0. My cosine is equal to negative 1. My tangent is equal to 0 over negative 1, which is 0. My cosecant, because c goes with s, of negative 3 pi is equal to what? 1 over 0, which is undefined. My secant, negative 3 pi, is going to be what? Negative 1. And my cotangent of negative 3 pi is going to be negative 1 over 0, which again is still undefined. So that's 9. Then I go to 11. So for 11, it wants to know what point do I get if I open up for A, 3 pi over 2. So my unit circle here is a pi over 2, 2 pi over 2. This would be 3 pi over 2, and that would have an xy of 0, negative 1. And that's my cosine sign. So I'm going to do the sine, the cosine, and the tangent. So the sine is negative 1, the cosine is 0, so the tangent is this over this, and guess what? That gets me undefined. My cosecant of 3 pi over 2 is 1 over negative 1, which is still negative 1. My secant 3 pi over 2 is 1 over 0, which is undefined. And my cotangent of 3 pi over 2 is going to be 0 over negative 1, which is 0. All right, so it's 11a. Let's go with B. So then when I look at 11b, it's negative. So I'm looking for negative 7 pi over 2. So if I go in the negative direction, I'm going this way. So here is 2 pi over 2 negative. Here is negative 4 pi over 2. Keep on going. This is also negative 6 pi over 2. And so up here would be my negative 7 pi over 2. And so my xy coordinate is going to be 0, 1, and that's my cosine sign. So the sine, the sine of negative 7 pi over 2, and then I'm going to do the cosine, and then I'm going to do the tangent, So sine is 1, cosine is 0. So tangent is 1 over 0, which is undefined. And then that means that cosecant is going to be 1. The secant is going to end up being 1 over 0, which is undefined. It makes no sense. And then cotangent is 0 over 1, which is 0. Okay, so that's a 9 and 11. Let's now do 15. So 15 is 5 pi over 4. So for part A, it's 5 pi over 4. So I go in the positive direction. This is 4 pi over 4. If I go one more, I'm down here at 5 pi over 4, right? Okay. Well, I know that it's very much going to relate to pi over 4 here in this quadrant. So if I know that this is square root of 2 over 2 and the square root of 2 over 2, if I add pi to get over here, it's going to have the same x and y coordinate. I just have to worry about the signs, and they're both going to be negative. So that's going to be my cosine sine in this case. So my sine of 5 pi over 4. See how we relate that to what we've already done? We're going to think of 5 pi over 4 as just 4 pi over 4, but we add a pi. That's why it's in this section. So now I've got cosecant of 5 pi over 4, and then we're going to do secant of 5 pi over 4, and boop, boop, boop. And then I'm going to do the cotangent of 5 pi over 4. And so that means that sine we saw was this, cosine we saw was this, tangent is their quotient, so that's 1. So that means that this is 1. And these just end up being negative 2 over root 2 and negative 2 over root 2. But the great thing is when you simplify that, that's just negative root 2. This is also negative root 2. Okay, so if I can give myself a little bit more room, I'll just move it over just a scotch so that you can let me expand that a little bit. It's this. Boop, boop, boop. So you can really see negative root 2, negative root 2. Okay, so that's A. So if I look at B for 15, it's negative pi over 4. So where does negative pi over 4 get me? Well, when I look at this thing, I go this way. I'm here at negative pi over 4. And I realize that if I add pi to it, that I can think of that as just related to pi over 4, right? So if I open up pi over 4 over here, it's going to be root 2 over root 2. I'm going to relate it to this guy, and I know that what we're going to have is the same x coordinates and the same y coordinate. They're just going to be off by a sign. In this case, the y is the one that's off by a sign. So I'm going to do sine of negative pi over 4, cosine of negative pi over 4, and the tangent. And then I'm going to do my cotangent, and my secant, and my cosecant. So in this case, my xy pair is my cosine sine. My sine is negative root 2 over 2. My cosine is root 2 over 2. So this is going to be negative 1. So is this. If I take this, and I'm going to resize that to give myself a little bit of room. I'm going to put it right here. Then this one is going to end up being 2 over negative root 2, which is negative root 2. This is 2 over root 2, which is root 2. And we're done with 15. So that was 15. Now we're going to do 27, 28, and 29. So 27, 28, and 29. Let's see what 27 has in store for us. So 27 just says as x goes to 0 from the right, what does the sine of x do? Now remember, from the right means bigger than 0. So as I come in bigger than 0, so I'm coming this way, closer and closer to 0, being bigger than it, what does my y-coordinate want to do? So as I'm going this way, my y-coordinate wants to be 0. It should be really clear. We also know that as x goes towards negative pi over 2 from the left, what does sine want to do? And again, the fact that we say that this is from the left means less than. So if I draw my picture, anytime you can, you should be drawing a picture. Here is negative pi over 2. So if I come from less than negative pi over 2, let's see, negative pi over 2 is over here. So if I come from less than negative pi over 2 on the number line, it would be like negative pi walking towards it. So this would be negative pi walking towards it, so I'd be coming this way, right? Because if this is negative pi, and I come from less than negative pi over 2, I'd be coming in this way, and it seems like your sine of x, in this case, wants to go to negative 1. That's what your y-coordinate wants to go to. Again, this cosine-sine pair was 1, 0. That's why I got 0 here. And this cosine-sine pair right here was 0, negative 1, and that's why we got our answer for that one. So that was 27. If I look at 28, so as x goes to pi from the right, and again, that means if you have pi, you're coming in from this side of it. So maybe coming in from 3 pi over 2, because this is 2 pi over 2. So coming in, going that direction, it wants to know, what does the sine of x want to be? So as you come in closer and closer towards pi from the right, what does your y-coordinate want to be? Well, this cosine-sine pair is negative 1, 0, so it wants to be 0. And it turns out that the rest of these are going to be exactly the same. So to see the rest of the reasoning, just look at the key and have a great day.